Hey everyone, and welcome to the Retro channel, and today we are checking out this thing, the lava-rsc Retro Famigame system. Yes, it is a Famiclone, but unlike most other Famiclones out there, this uses the original CPU and PPU that you'd find in a Famicom, or an NES for that matter. So this offers 100% compatibility, but also gives us a few neat video output options, as you can see from the rear here. So unlike the original Famicom, which only has an RF output, this covers both composite, S-video, and RGB. And it does it in a way that adds absolutely zero lag to the video signal. So this will also work with light gun games or Zapper games, and also perfect for people who do speedrunning because, like I said, no lag, not even a single frame, not a scan line. I think talking to Adrian from Adrian's Digital Basement, who also picked up one of these, and I'll link to his video up in the corner there and in the description, he tested it out and found that there was 140 nanoseconds of lag, which means it'd be pretty much less than a pixel of lag, which you would never be able to detect unless you're looking at it on an oscilloscope, which is what he did. So yeah, we both picked up one of these things as we were chatting about RGB mods for the Famicom and the NES, and yeah, he came across this thing, which is made by a person in China who obviously sells these on AliExpress, so they are still available if you want to pick one up. Of course, if you're in the United States, your mileage may vary there. Sorry, really sorry. But yeah, this is an awesome little system, and since having this thing, I haven't really touched the Famicom or the NES. So let's go through some of the features that this thing has, and then we'll plug it all in and see how it performs. So on the front here we have two controller ports, so you can use your original NES controller or maybe a modern, wireless controller if you've got something that plugs into there. You've got our power and reset button, and this thing in the middle, which would normally be where the eject lever is on an original Famicom, this actually has a button to switch through different palettes, which we'll also have a look at once we get this hooked up. Of course, we've got our cartridge port, which matches the original Famicom. So this is the 60-pin port, which is designed for original Famicom games. I'm going to be using it mostly with an EverDrive, obviously a Famicom EverDrive, so no need to worry about, trying to find original cartridges. I think I did borrow a few off Mr. Lurch, which I do need to return to him because he's probably been missing them. The only one I recognize, obviously, is Super Mario Brothers. We'll have a look at this once we get this hooked up as well. So yeah, obviously doesn't support original NES cartridges. I think you can get adapters which basically go from a 60-pin to a 72-pin that you'd find on the NES, so it is possible to use NES cartridges with this, but if you get yourself a Famicom EverDrive, you don't really need to worry about that. Over on the side we do have the 15-pin connector, which is the same one that you'd find on an original Famicom under this little cover here. I think that was mostly used for third-party controllers because the original Famicom, the controllers are hardwired. So yeah, and I think also the keyboard, the family computer keyboard, also plugged into there. I don't have one of those on hand, so yeah, I won't be testing it out with the new Famicom, but I do have a Famicom disk system, so we'll see if that works with this thing. But in theory, it shouldn't have any issues. Around the back, we've got a number of ports, obviously composite video, audio, another 3.5mm audio jack, power in, which is I think 9 volts DC. The polarity shouldn't matter because this thing has a bridge rectifier inside, so it doesn't matter if it's center positive or center negative. And there is also a 10-pin mini DIN connector, basically the same one that's used on the Saturn. And this is where we can get RGB, S-video. I think it also has composite video and of course audio on there. So yeah, plenty of options for audio outputs, but if you want RGB or S-video, you're pretty much stuck with using this DIN connector, at least in its stock configuration. So this pretty much has all the features from both these consoles, plus a few extras, in a very nice injection molded case. These are also available in different colors, so yeah, I'll put a link to where you can find these in the video description. Let's get this thing hooked up, see what it does. So while this thing did include a power supply, it doesn't have an Australian plug, so I'm not going to be using this. However, I did decide to crack it open because I was curious about what the construction was like on the inside. And I'm no expert, but it actually looks somewhat decent. The capacitors in here are the Capson branded, so I don't know about the quality of those capacitors, but overall I wouldn't be too concerned using this power supply. However, I do have a nice triad power supply which obviously has the Australian plug on it, so this is what I'm going to be using instead. So for starters, I'm just going to use composite video, so we can just use the provided RCA output jacks. And let's throw in a cartridge. We'll go with Super Mario Brothers. Power on. And there it is, Super Mario Brothers. This is composite video, so it obviously doesn't look perfect, but I'd say it actually looks better than what you get from an NES or even a composite modded Famicom. So yeah, not too bad. We'll have a look at S-Video and RGB soon enough. But first, let's plug in a controller, give it a whirl. And there it is. So yeah, as you can hear, it is running at the correct speed because this is an NTSC game on an NTSC console. That's unlike the PAL version of Super Mario Brothers, which actually sounds like it's running faster than it should. That's just what it sounds like on a PAL machine, and that's pretty much what I grew up with. So this actually sounds a little bit slow to me, but I'm sure I'll get used to it. In fact, I pretty much already have. While we're here, let's have a look at the different palettes that we can choose from, because this is a pretty familiar screen for everyone. So I think that's the original NTSC palette, so yeah, it looks pretty accurate to me. But if we push this button, we can also get the FCEUX. I think that's an emulator for the NES. And to be honest, I'm not a fan of that palette. It looks totally wrong. Oh, that's the NTSC palette. So yeah, a little bit more brown and the sky's a little bit more blue, I guess. There's the PC-10 palette, which is the arcade NES multi-system. That palette looks totally wrong to me, but I'm sure it matches the original PC-10. And YUV, that was the palette that we were originally looking at, which is what I usually have this thing set to, because that seems to be the most natural looking to my eyes. Of course, everyone has their own opinions on what the original NES palette should look like. I like the YUV, so that's perfectly fine for me. It is possible to load different palettes onto this console, but they're sort of rolled into a firmware update, so you can't just stick an SD card in here, which yes, it does have an SD card slot for firmware updates, but those updates are only provided by the original developer of this, so changing the palettes means contacting the developer, getting them to roll those palettes into a new firmware file, and then obviously updating the firmware. So I wouldn't expect that to happen very often. I'm sure the developer doesn't want a million requests for different firmware updates, but yeah, I'm happy with the YUV palette, so that's what I'm going to stick with. Adrian did manage to get a different firmware with a few palettes that he chose, and to be honest, neither of us were that impressed once we actually saw them running on the machine. So I'd say if you're looking at getting one of these things, expect to only have those 4 default palettes to choose from. You can also switch through the palettes using the controller, so I think you hold select and then press up. Yes, and that'll cycle through the available palettes. There is also an in-game reset, so I think holding select and then pushing A will reset the game. Yeah. So we've seen what this looks like with composite. Let's switch over to RGB, see how that looks. So what I'm going to be using is a cheap and nasty Saturn to SCART cable. This is obviously set up to do RGB, so it should work with this thing, but I wouldn't expect perfect results because I think there's some very thin wires and zero shielding going on here. All right, RetroTink is set to SCART, so this should work. Yeah, there we go. Pretty much perfect. I can't really fault that image. Make sure we've still got sound. Yes, we do. Now, the frame rate might look a little bit choppy because although I'm capturing this at 59.94 frames per second, this video is going to be rendered at 25 frames per second, so yeah, ignore if it looks a little bit choppy. It actually looks perfectly smooth to me. Cool, so that's how it looks with RGB. Now when it comes to S-Video, I don't actually have a cable to do that because yeah, it also requires using the DIN connector and well, all I've got is this SCART cable. So what we're going to do is make some modifications and repurpose a couple of these audio jacks to instead output Luma and Chroma, or S-Video. Basically the same thing that Adrian showed in his video. I thought it was a pretty good idea, so that's exactly what I'm going to do to mine as well. And while we're there, we'll also update these labels on the back here. And yes, I am aware that it says video. So let's crack this thing open and take a look inside. It looks like it's got Torx T10 bits. Yes, they are definitely Torx T10. Alright, that should be the bottom cover freed. And then on the inside, we've got 2 Phillips head screws. Because why not? Now, I'm pretty sure there's a power LED cable that we need to disconnect. Yes. Oh, it actually goes up to the pallet button, which also has, pretty sure there's an LED inside there. Maybe there's not. Is it on the board? No, must be in there. Pretty sure there's an LED on that board somewhere. That would explain why there's 3 wires instead of 2. Yes, there we go. There's actually 2 LEDs. Interesting. Okay, they're both just connected together, so they both turn on at the same time. I was thinking that maybe there was a different color in here that I hadn't seen yet, but yeah, they're both going to be just red LEDs, I guess, to better light up the button on top. So here's a quick look at the board. Pretty much everything from the cartridge port forwards is almost the same as an original Famicom. And of course, like I said, we have the original PPU and CPU installed in this machine. Or is that the CPU? One of them is a CPU, one of them's PPU. These would have no doubt been pulled from a original Famicom. So yeah, that's what gives us the 100% compatibility. There's no FPGAs or anything up the front here, and yeah, no Nintendo on a chip blobs. And up the back here is where all the sort of modern stuff is. So yeah, this chip here I think is taking the outputs from the PPU and giving us, you know, our RGB, S-Video and Composite. There's some stuff to obviously handle the SD card slot and update firmware files, that kind of thing. And then there's a little THS, it's probably a 7374 video buffer. As I mentioned, there is a bridge rectifier on these things, so it doesn't matter what polarity you plug into the back here. As long as it's around 9 volts, you shouldn't have any issues. Now, I did try this also with a 9 volt AC adapter, and the machine wouldn't power on. So I only tried that for, you know, a second, and as soon as I saw it wasn't working, I switched it back off and unplugged it. So I don't know why it didn't work with just AC, but yeah, I'd highly recommend using a DC power supply. Of course, you can always use the one that's included with this thing, provided you can plug it in and you don't pull it apart. So here's our rear plate. Yeah, it's just a PCB with some silkscreen text on it. Obviously there's a spelling mistake, and the audio left and right is not going to match once we swap that over to Luma and Chroma. So rather than messing around with this thing, I basically just copied the dimensions of it and made my own panel. I didn't go for the gold because that's more expensive and I'm a tight ass, but yeah, it looks perfectly fine. One thing to note is, yeah, I did actually put AC/DC. I'll have this available on my GitHub page, but yeah, I'm going to take out that AC text because I don't recommend trying to use AC with this. I'll also put up a version that has the original left and right audio, just in case anyone wants to replace their rear panel with one that doesn't have any spelling mistakes. I did also widen a couple of these RCA holes because they kind of struggle, at least certain cables will struggle to fit in there properly. So I widened these up a little bit just to fit the chunkier RCA plugs. So let's modify this to output Luma and Chroma on these jacks. Obviously, you know, RCAs are not ideal for S-Video, but you can always find little adapter cables like this that go from two RCAs to a regular S-Video jack, so not such a big deal. So the first thing we'll need to do is cut off the trace that carries the audio to these two jacks. I think there's another trace on the top side that then goes from the right jack over to this 3.5mm output. So even if we cut these two off, we're still going to have audio available on the DIN connector and audio available on the 3.5mm. We might just need to put a bodge wire to go from here over to here. I think what I'm going to do is cut right next to that solder joint. That way, if I ever want to reverse this, it should be pretty easy to blob some solder over there and reconnect everything. All right, that's one down. And that's now cut as well. Might cut this off on the other side as well, just so we don't have the Luma signal that'll be on this jack just going across this empty trace, because Luma is very prone to picking up interference, so better to keep that as short as possible. So that's our two RCAs freed up, but keep in mind there is a trace going from this RCA to the 3.5mm on the top side somewhere, so we're going to need to cut that off as well. Yeah, I can see it between the two jacks. Let's cut that right in the middle just in case I ever want to reconnect it. That should hopefully do. Let's double check. So we shouldn't have any connection from here to here, and we don't. All right, so we need to run a wire from this point here, which is the original audio signal, over to the 3.5mm jack, and then find out which pins have Luma and Chroma on this DIN connector and run them over to the two RCA jacks. What wire would I like to use? I'll use my massive roll of orange wire. All right, that should be our audio reconnected, so it should also be on this side of the jack. Yeah, that's all good. So to figure out the pinout for this thing, I'm just referencing Adrian's video because I'm too lazy to figure it out myself. So it looks like that's Chroma. Okay, so that's Luma, that's Chroma. Yeah. All right, there we go. So I tried to keep the Luma wire as short as possible because that's one that's most prone to picking up interference. And yeah, obviously audio goes across the top and Chroma routes all the way around here. Let's just make sure I haven't accidentally bridged anything. So they shouldn't be connected. They're not. That's good. That's good. That seems fine, that's good. No, I think we're good. Let's just test this before we go putting it all back together. Now, unfortunately, the cable that I'm using, the colors are reversed, so that's actually going to be Luma. That's got Chroma. All right, here we go. Yes, perfect. And yeah, looks miles better than Composite. Almost verging on RGB quality, I'd say. And when it comes to audio, I can just use a 3.5 to 2 RCA connector. So we still should have audio available there. Let's see. Okay, perfect. All right, that is the S-Video mod done. What I do want to have a look at though is whether or not this is outputting the correct voltage levels on Composite, S-Video and RGB. So let's take a quick look at that on the oscilloscope because it seems to be fine, but I just want to make sure it's perfectly safe to hook up to any other monitor. So I've just put in the EverDrive so we can load up the 240p test suite, and we'll just use the solid white screen just so we can see our video voltage levels properly. All right, so I'll just plug this into my video debug board, and then we can probe all these things on the oscilloscope with the proper 75 ohm termination. So looking at the Luma signal, that looks pretty good. Looks like our peak-to-peak voltage is around 1 volt according to the delta Y figure. And if we look down here, our sync tip, yeah, 300 millivolts. That leaves another 700 millivolts for the brightness information. Yeah, that's a perfect Luma signal. As for chroma, there's not a lot of chroma information here because we're looking at a white screen, but these would be the color burst pulses, which should be around 300 millivolts. Yeah, 320-ish. There's probably a bit of noise in there. Yeah, once again, perfect S-video signal. I imagine composite is going to look fine, but we'll double check that while we're here. Oh yeah, once again, that looks good to me. 300 millivolts for our sync tip. Yeah, around 300 for the color burst, and of course 700 for the brightness. Now, RGB might be a different story because I'm not sure if there's any components inside this cable. Remember that it is designed for a Saturn, so I don't know if they require components inside the cable, but yeah, let's take a look. We'll find out soon enough. Also curious as to what signals are going to be available on this connector apart from the RGB, so we can use the breakout board again, and if we hook on to here, this should be our sync. Now I don't know if it's going to be using composite video for sync or Luma for sync or just plain C sync. Let's see. It's composite video. So that's not ideal. Normally I'd prefer to use sync on Luma or C sync, but in this case I don't think it really matters. I mean, this cable is, like I said, very cheap and nasty, no shielding, so yeah, it is what it is. But let's first check our RGB colors, and they are AC coupled, which is why the waveform is going down off the bottom of the screen. They should be around 700 millivolts. Yeah, perfect. Red is good. Green is good, blue is good. Do we have blanking voltage? Looks like we do. Yes, looks like about 2.5 volts for RGB blanking, which is perfectly within the 1 to 3 volt range, which means this should also work with any SCART TVs that rely on that blanking voltage being there in order to switch over to RGB. Function switching should be between 5 and 12 volts. Let's see. Yeah, it's sitting on 5 volts. Once again, that's perfectly fine. So really the only thing I'd like to change with this is using C-Sync for the sync source rather than composite video for sync. I don't think there's any way to modify this cable because, well, this DIN plug is all molded, so yeah, I can't exactly cut this open and rewire it. So instead, let's double check inside the SCART head, see if those unused pins are actually connected on this end, and if the wires are just floating around inside this SCART head just unconnected. If I can crack this bastard open. Here we go. What have we got? So there are two 20 microfarad caps on the RGB lines, which is good. So they're all AC coupled. There's, yeah, resistor between the function switching, which has 5 volts, and the RGB blanking, which has 2.5 volts. So that's just halving that voltage basically. That's also good. Yeah, again, very thin, pissy little wires, but doesn't seem to matter that much. And it doesn't look like they've wired up C-Sync from the DIN connector into this SCART head. So yeah, this cable is definitely only wired up to use composite for sync, and there's no real way of changing that. Right, future me jumping in here because I actually forgot to test one more modification that I just remembered about while I was editing this video, and that is to do with the composite video output. So as we saw before with the composite video output, it looks pretty good, but still very composite-y, and it didn't help that I'm looking at all this through a small preview window in OBS, which is also why I didn't spot that noise in the RGB signal. But when I was talking to Adrian about this thing a few months ago, he mentioned that there may be a way to improve the composite video output, and that was by changing the circuit around this video encoder IC. He actually looked up the part number for this thing and managed to find a datasheet. And in the datasheet, which is a BH7240 AKV, it mentions that there is a chroma trap filter on the composite video output. Yeah, pin 10, luminance trap filter connection pin. Connecting a trap filter eliminates the chrominance band component included in the luminance signal and reduces the amount of chrominance color. This is effective only on the composite video output. So if we scroll further down in this data sheet, we can actually find an example of how it's hooked up. And we can see here pin 10 should be connected to an inductor and capacitor and then to ground. And that's exactly what we find on this board. So there's the video encoder IC, and that inductor is this guy right here, and there's the capacitor. So I did try this ages ago, but I don't think I got any screenshots of what it looked like. So we're going to remove that inductor again and test it out, see if it's any better or worse than what we had before. So I'm just going to try and heat up both sides just with the soldering iron. I do actually have soldering tweezers, but too lazy to grab them right now. All right, that's the inductor freed up. I'm actually just going to deliberately tombstone that so I don't actually lose it. But yeah, that should be that inductor and also the capacitor removed off pin 10. Let's see what this does. All right, and there we go. That is the result. And yeah, I do actually think that looks better than what it looked like before. The edges are a little bit cleaner. Maybe there's a little bit more chroma bleed, but I think I can live with that. I think I actually prefer this over what the stock output looked like. So yeah, that was just an extra little mod that I wanted to include in this video. Obviously, if you get one of these, it's up to you if you want to mess around with the composite video or the Luma trap. But for me, I think removing that inductor actually looks better than what it looked like before. So I'm going to leave it that way. And now let's go back to past me. So I'd say let's throw this thing back together and test it out with the Famicom disk system. And then we'll hook it up to a CRT, see how it performs on one of those. Cool, there we go, all reassembled, and yeah, ports clearly labeled, and there's no more spelling mistakes. Yeah, like I said, I'll have this available on my GitHub, along with a version that has the regular left and right audio for these two. So yeah, you can download that, send it off to your favorite PCB manufacturer, and yeah, have a new backing plate for your lava-rsc if you like. All right, the Famicom disk system. A big thanks to Nathan for giving me this. He said it needed a new belt and then it should be good to go. And yes, that was all that was wrong with it. Just needed a new belt, which he even supplied me with, along with a few discs. So yeah, interested to check these out. So this just plugs in to the Famicom the right way around. The disk system does need separate power though. Which is going to be tricky. How am I going to do that? I guess I can power it off my bench power supply. I assume it's 9 volts center negative. Plug that in the back there. And with any luck, this should just work. Ah, yes, there it is. Why is the video gone all screwy? Why is that not happy? Is that from the disk system? That's very unhappy, isn't it? Oh, so I unplugged the bench power supply and it stopped. Right, so it must be picking up interference from somewhere there. Let me find another power supply to use this with, or even, I suppose I could put batteries in this thing. I don't think I have that many C cells though. Well, I do have this one, which is a cheap and nasty 9-volt center native. Hopefully it doesn't kill the disk system. Okay, well it's plugged in and it's not messing up the image anymore, so that's a good sign. Let's throw in a disk, see what happens. Hey. Done. So yeah, the disk system is pretty impressive. Like, it only takes a few seconds to load a game. Not that much different than, you know, what you get from a cartridge. And that's it, the game is loaded. So yeah, this thing works perfectly fine with the Famicom disk system, as expected. Just make sure you use a really cheap and nasty power supply for the disk system. I don't know why it gave me that trouble with my bench power supply, because that's a linear power supply, so there shouldn't be any noise on the outputs, but well, there we go. So yeah, thank you to Nathan for the Famicom disk system. I will actually put it to some good use at some point. Yeah, let's pull down a CRT, see how this thing looks on that. Right, we'll use the good old Commodore 1084 SP1 for this. Now these monitors don't have a SCART plug as such, but they do accept analog RGB over a DB9 connector. So this is just a little adapter that yeah, does that conversion, and also outputs the audio to the two RCA jacks for the back of this monitor. So let me plug this thing in. All right, let's power this thing on, and there we go. That looks absolutely perfect to me. It is flickery on the camera. Yeah, sorry about that. The camera is set to 50 Hertz because that's usually what I'm recording, but because this thing is outputting 60 Hertz, there's a bit of a mismatch. I don't actually see that flicker in real life. Let's load up one of the games that uses the expansion audio from the Famicom, because, well, this is basically a Famicom, so in theory that should also work. Let's go for Castlevania. I think it's Castlevania 3, but it's called... I'm not even going to try to say that. Whatever that is in Japan. And there we go. So that's definitely expansion audio working. So it's got those extra sound channels going on. And yeah, once again, it looks absolutely perfect in real life. I can't fault that. And it also sounds great. There is a bit of a buzz from the speakers, depending on what's on screen. That's just going to be down to this cheap and nasty SCART cable. I'm not too worried about that at the moment. So yeah, here's what the US version of this game sounds like. Pretty boring, pretty pathetic. We should be able to reset. I think it's select an A. Is it? Yeah, that takes us back to the menu, which is even better. Yeah, Super Mario Bros. 3 looks absolutely perfect. Amazing. And for one final test, let's pull out the big guns. All right, here we go. Oh yeah. Oh. Oh no. Started out so good. Hide behind that tree. So yeah, like I said, Zapper works perfectly. There is absolutely no lag on this thing. What else can I say? Ah, better finish the round. Right, that's enough of that. So yeah, what can I say? I love this little machine. It is like the perfect Famicom slash NES. Couldn't be happier with it. So that is it for this one. I will put a link in the video description to where you can find these consoles. I'm not affiliated with the creator or seller of these things in any way, so there's nothing in it for me. I just really like it and wanted to show it off. So yeah, that's it for this one. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are in the video description. You'll get ad-free early access to all videos, along with discounts on the Tindy store and the occasional exclusive behind-the-scenes stuff. And yeah, thank you all for watching, liking, subscribing, all that YouTube bullshit. I will catch you in the next one. Bye.